Okay, so today I'm going to go over elementary rate laws. So looking at elementary steps and determining our general rate law from this. So let's start with number 1. So we're given the following 2 elementary steps, and we want to derive our overall reaction along with our rate law for this. So we want to look at these, combine the 2 equations, and look where we are producing or where we have intermediates, get rid of those, and then combine the rest of it. So those are our intermediates, N2O2. We combine the 2 equations for our overall reaction. We get 2NO goes to, 2NO plus O2 goes to 2NO2. And then when we write our rate law, we start with the rate of our slow step. So our slow step, the rate would be equal to rate equals K2 N2 O2 and then O2. Now, I'm going to rewrite this in a different color. This N2O2 needs to be replaced as it is an intermediate. So we can't write our rate in terms of intermediates. So we look at where it is produced. We use that equilibrium process to find out how to rewrite that in terms of N2O2. Or not in terms of N2O2. So we have the rate of our forward reaction for that. K1 NO squared, and then the reverse, K minus 1, N2O2. We set the 2 rates equal to each other, and we get K1, NO squared equals K minus 1, N2O2, and then we solve for N2O2. And then that expression will go in for N2O2 concentration. And what we get is rate is equal to K2, K1, K minus 1, NO squared, O2. And then this is just a constant, so it goes to just the constant K, NO squared O2. Okay. There's the rate and our overall reaction. Okay, we've got another set of elementary steps. The first one in this case is our slow step. So our rate will be based on that. Let's start out by writing our overall reaction. So let's look for intermediates. There's an intermediate right here. Oh, this is. And we have an intermediate right here. And we have an intermediate right here. Lots of intermediates. Okay, so overall, we get H2 gas plus 2 ICl gas goes to 2 HCl gas plus I2. We want our rate of our slow step. We have rate is equal to K1 H2 ICl And as neither of these are in terms of intermediates, this would just become our rate. So, easy peasy. Let's try the next one. Got the following steps. Want to write the overall reaction. Okay. So let's look for intermediates. Here's an intermediate. Here's an intermediate. And the rest of them are reactants or products. So we have 2 CE 4 plus. Oh, we also have that right there. There we have a catalyst. Okay, so we have 2 CE4 plus, oops, let's go back to black, plus thulium plus goes to 2 CE3 plus thulium 3 plus. Okay, so there's our overall reaction. So now we can, after looking at that, we can identify reactants, products, or intermediates, or catalysts. So Mn2 plus, this would be a reactant, or sorry, a catalyst. Mn3 plus would be an intermediate. CE4 plus would be a reactant. CE3 plus would be a product. Mn4 plus would be an intermediate. Thulium plus would be a reactant. Thulium 3 plus would be a product. Okay, now we want to look at what our rate law would be. So if we assume the catalyst is involved in the rate determining step, what is the rate law for this reaction? Here is our catalyst. So our rate would be equal to K1 CE4 plus Mn2 plus and then it says why is the uncatalyzed reaction so slow? If we look, our uncatalyzed reaction is so slow because if we do not have this substance, our reaction would not actually proceed in any way because this is our first redox process. So it does the first redox process. So without it, there is no way to reduce the cerium 4 plus. Okay, and that's everything.